Okay, so now let's have a look at differentiating some chain rule examples. Now just remember, chain rule is nice and simple. It's just simply differentiate the outside function and then gradually work your way inside and keep multiplying by the derivative of that. Okay, so let's start off with y equals 5x cubed plus 8x all raised to the power of 2. Now are you happy there's two functions going on here? There's a function within a function. The inside function is 5x to the power of 3 plus 8x. And then the outside function is just basically squaring that. So to differentiate, what I'm going to basically do is first of all differentiate the outside function. In other words, the squaring bit. So if I square it, I get 2. And if I reduce the power by 1, I just get the 1 up here. And of course, the inside function stays the same. So in other words, in this case, the 5x cubed plus 8x, which is the inside function, stays the same. Okay. Now I'm just going to get rid of that power of 1 because, of course, that's not going to change anything. Okay. Then I need to multiply by the inside function. So in other words, the 5x cubed plus 8x, I need to multiply by the derivative of that. So I put it in bracket. Multiply by the derivative, that's 15x squared plus 8. Okay. Now all I'm going to do is just tidy it up ever so slightly. So I could leave it like this if I wanted to. But in fact, I'm going to expand the brackets as much as I can. So in other words, if I expand the 2 over the first bracket, I get 10x to the power 3 plus 16x. Then I need to multiply that by 15x squared plus 8. And again, I'm just going to multiply these two brackets out. So everything in the first bracket has to multiply with everything in the second bracket. So 10x cubed times by 15x squared, that's going to be 150x to the power 5. Then 10x cubed times by 8, that's going to be 80x to the power 3. And then 16x times by 15x squared, that's going to be 240 x to the power 3. And then finally 16x times by 8 is going to come out as 128x. Okay, so that'll be the derivative. So again, start out the outside function and multiply your way inwards. Okay, now let's have a look at this one. So let's have a look at y equals the cosine of 5x to the power 3 minus 8x. Okay, so in this case, my inside function is my 5x cubed minus 8x. My outside function is the cosine of whatever's inside my brackets. So that means that the derivative, so I'll write dy by dx, is going to be equal to, well, first of all, let's think about the derivative of cosine. Derivative of cosine, remember, is negative sign. You could draw your circle if you're not sure. That's going to be negative sign, and I'm going to leave the inside function alone. So the 5x cubed minus 8x. But then I need to multiply by the derivative of the inside function. In other words, the function I just left alone. So that's 5x cubed minus 8x. To find the derivative of it, that's going to become 15x squared minus 8. Okay? And that's how I'm going to leave my answer. Okay, that's fine as it is. All right, fine. Let's have a look at this one. So let's have a look at y is equal to the square root of the natural log of sine of x squared. Okay, so lots of functions within functions here, but just keep your wits about you and you'll be fine. Well, first things first, I'm not going to write it as square root, I'm going to write it as to the power of half. So therefore I've got it as a power rather than as a square root function. Okay, so I'm going to write the natural log of sine of x squared, but instead of writing it as square root, I'm going to write all of this as the power of a half. So let's work my way inwards, okay? First things first, that's my inside function, the natural log of sine of x squared. So I'm going to leave that alone. I'm just going to focus on the derivative of the outside function. So dy by dx will be equal to, if I differentiate the outside functions, so something to the power of a half. Bring the power down, so half of something, okay? And reduce the power by 1. Well, a half take away 1, that's negative 1/2. And then I leave the inside function alone. So the inside function is just natural log of sine of x squared. Okay. Now I need to go back and multiply by the derivative of the inside function. So let's think the derivative of natural log of sine of x squared. Well, again, that's a function within a function. Okay. So now I'm going to look at the natural log of sine of x squared, where the sine of x squared is my inside function. So let's think. Well, okay, the derivative of a natural log of something is just 1 over that function multiplied by the derivative of that function. So just 1 over that function first of all. Okay, so 1 over the sine of x squared. That's my natural log function. Just remember, derivative of a natural log just essentially is just 1 over that function. Okay. Now I need to work my way inwards and need to multiply by the derivative of my inside function, which is the derivative of sine x squared. So let's think. The derivative of sine x squared, well, now my inside function is the x squared. So the derivative of sine is going to be, well, let's think, it becomes cos. Okay, so I'm going to multiply by cos. I'm going to leave the inside function alone, which is x squared. And I'm going to multiply it then by the derivative of the inside function. So the derivative of x squared, that's 2x. Okay. Just remember, I'm just working my way inwards. I'm leaving the inside function alone with every derivative, and then I go back and multiply by the derivative of the inside function. Just here, I'm kind of having to work my way outwards, away from the outwards to the inwards. Okay. So first of all, I differentiated the something to the power of a half. Then I differentiated the natural log function. Then I differentiated the sine function. Then I differentiated the x to the power of 2 function. Okay. So I could tidy this up if I wanted to. For example, I can see that half and the 2 is going to cancel. Okay. I can see here that if I have anything to the power of negative a half, that's 1 over the square root of that thing. So let's have a look. I get 1 over the square root of the natural log of sine of x squared. Okay. Times by 1 over the sine of x squared times by the cosine of x squared. So I'm actually going to write this as the cosine of x squared over the sine of x squared. Okay, and I've still got to multiply by the x hanging around at the end. So I'm going to multiply all of this by x. Now let's have a look. I could write, if I wanted to, cos over sine as cot. Okay, if you're familiar with your reciprocal trig functions. But to be honest with you, leaving it something like this, that's absolutely fine. We've kind of got the spirit of what's happening here. Now last one, let's just have a look at this one. Let's try differentiating. So we have f of x is equal to e to the cosine of the natural log of x cubed minus 6x. All right, let's have a think about this. So first of all, to differentiate it, I'm going to have to first of all work with the e function. So I've got my outside function, leave the inside alone. So this is my inside function. It's e to the power of something. That's what I want you to think. E to the power of something. What's the derivative of e to the power of something? Which is simply e to that thing. Okay, so it's e to the cosine of the natural log of x cubed minus 6x. But then I need to multiply by the derivative of my inside function. So my inside function I've got in blue up here. What's the derivative of this? Well, it's kind of a function within a function. So let's work our way one more inwards. Let's treat that as the inside function, so the natural log of x cubed minus 6x. So therefore, what's the derivative of the cosine of something? Well, the derivative of the cosine of something is negative sine. So I'm going to put this in brackets. So it's going to be negative sine. And I'll leave my inside function alone. So natural log of x cubed minus 6x. Okay, and then I multiply by the derivative of my inside function. So in this case, I've got the natural log of x cubed minus 6x. Well, I know the derivative of a natural log function is just 1 over that function. So it's going to be 1 over x cubed minus 6x. Okay. Then finally, I need to multiply by the derivative of the inside function. So the derivative of the x cubed minus 6x, that's going to give me, and I'll put it in brackets, 3x squared minus 6. Okay. So just a little bit of tidying up then. Let's have a think. I know the whole thing is going to be negative because I've got negative sign in there. So I'll stick that negative out first of all. So I get negative, and I'm going to write this as sine of the natural log of x cubed minus 6x. I'm going to start off by taking this term here. Okay. Then I'm going to multiply it by this fraction. Okay. So this fraction basically means on the denominator, I'm going to end up with the x cubed minus 6x. Then I need to multiply by this still. Okay, so I'm going to stick that in a bracket as well. So I've got 3x squared minus 6. Then I've still got the e to the power of the cosine of the natural log of x cubed minus 6x. Okay, cool, fantastic. So that there would be the derivative. It's a bit long, it's a bit awkward, but just keep your wits about you, work from the outside inwards, and you'll be fine.